All right, today we're doing stuff that's not as directly related to 3D printing, but it's kind of on the edges of it. One of the things 3D printing lets you do is reproduce things or make things that aren't made anymore. That's what our idea is with this little lamp cover. You just can't really get new ones, and so maybe we can create a new version of this with 3D printing. So one of the things that allows that is either being able to model things, in CAD very accurately, taking calipers and measurements and things like that. And sometimes that works. Some things are not as rigidly made. They're more organic shapes, kind of like this. This is a little bit, it's got curves and everything and undercuts in here and tabs. This we could probably get pretty close with some just CAD modeling, but there are also options for getting geometry into a digital form that aren't just making it from scratch. So we're going to look at one of those options today. We're going to look at 3D scanning and see how what that process looks like. There's actually several different versions of 3D scanning. We're at the lower end here with our equipment. This is what we're going to be using. Over here we've got the Revo Point. This is one of the original ones, so it's not I think now the current one is there's a 3 Revo Point Pop 3 and there's a Mini, and they both are the newer versions. This is a couple of years old, so it's not as quite as high fidelity as the others, but it'll do what we need it to do, at least get us started. But do know that there are much higher, much more expensive versions of this kind of thing out there. Let's take a look at it. Let's see, I had it over here. Nope, yeah, that's it. So this is one of their newer versions over here, the Range 3D. That one's for bigger scans, so larger areas you're trying to scan. The Revo Pop, I think this is the 1. It might be the 2. I think it's the 1 though. It is kind of an intermediate, so it's not for really large areas like a house, and it's not really for tiny details like a little figurine or something. So it's kind of in the middle. The stuff I'm going to scan today is on the smaller side, but it'll be fine for what we want to do. So let's just look through some of their details here. You can kind of see them holding. I've got a turntable set up over here, but you can also, if you have a powerful enough phone, you can connect these to your phone or a tablet and kind of do some remote scanning. I'm going to be sitting here with the computer scanning. It doesn't scan on its own. It does need some other processor to go collect the data. This is kind of what we've got over here. This is the Pop 3 version though, but it looks very similar. It's just the 3 has a little bit better technology in it. Let's see if they show a picture of how this works. Well, no, but this other site does. So this is a different company here, higher end company, or not higher end company, but higher end scanning tools over here. And they had a picture here. So this is the objects that they're scanning. One of them's kind of off the page a little bit. Let's get it where, there you go. So you can see these lines. Those are not part of the object. Those lines are being projected onto the object. This is called structured light. So if I project a pattern that is a known pattern, so these known patterns are normally like just strips of lines. So you can kind of see this is probably just a bunch of parallel lines that are being projected onto this surface. Then a sensor on the same device that's projecting this pattern, usually, I mean, originally they had kind of separate projector and sensor, but now it's all compact into one thing. A sensor can go and take pictures essentially of that pattern, and since it knows the pattern was supposed to be a bunch of parallel lines, but when it looks at it, the lines are distorted because they're having to go over the geometry of the part, then it can infer what the geometry must have been to deform the lines in that way. And so this is structured light scanning. There's other types of scanning like the LiDAR that might be on your tablet or your phone. It's a time of flight thing, so it actually sends out signals and they bounce off and come back, and depending on how long it takes for them to come back, it knows the distance away that particular point was. Laser scanning works similar to that. What else is there? So there's laser, there's structured light. There are like direct methods where you actually go and take a probe and touch the surface mechanically, and those probes are connected to arms that that know their position in space, and they know that, oh, you touched a point here, I know where that position is, and then you touch another point, I know where that position is, and it can physically go and recreate geometry. Those are called coordinate measuring machines, CMMs. Those are usually much more expensive. They're for large scale things, although they do make desktop size ones too, for maybe like a small engine block or something like that size, like a little one cylinder engine on a lawnmower. So there's that version. There is photogrammetry, which is you take a ton of pictures, like hundreds of pictures all around an object, and the only data there is the picture. And the software, usually it takes a lot of processing power, but the software can take those pictures and figure out what geometry is inside the pictures based on, there's a whole bunch of pictures all around the part. There's some free software for that, and paid software. Most of the paid stuff takes advantage of the cloud so that you can upload your pictures and then offload the processing to the cloud somewhere. But there is at least one piece of software, Meshroom I think is what it is. Let's check real quick. Meshroom. Yeah, this Alice Vision Meshroom, where all the processing can happen on your computer locally. So it does take some processing power. I think it takes a particular graphics card, maybe an NVIDIA, I can't remember. But you can do that locally under the right circumstances. It will be slower unless you have a supercomputer at your house. But it does work. It is heavily dependent on the quality of the pictures you take. So you need good lighting, you need lots of pictures, you need good focus length. So a lot of setup in getting the right pictures. But then once you have those, then there's a good chance you'll get some decent or at least usable geometry out of it. Polycam is a good, I think that's the name of it, a good app for like the iPad. It takes advantage of the LiDAR that is on newer phones and tablets. It does, I think it has a free version and a paid version kind of thing. I don't know. We might look into that one. I think I have it installed somewhere. But what we're looking at today is this, and again, this is an older version of the technology. I've got a little Iron Man here, our scanner. See if you can see. It has some sensors on it. I guess they're active right now because you can kind of see the lights of them. But there's a camera. There's a camera for taking color information also. So once your model is created, it can actually create a colored textured model. But the real thing that we want is the geometry. So let's go to its software. Have it pulled up here. So this is kind of, I put my, this is basically the only spot that a lot of information doesn't come. So I put my picture down in the bottom corner here. But this is their RevoScan 5 that it's free with the hardware. So without the hardware, it doesn't really do anything. But we'll go over here to scan. Oh, I might have unplugged my scanner. Let's see. I may have to restart the software because, or let's just try unplugging and see if it can pick it up. It was working just a minute ago, so let's see. We got the USB connection there. Let's see if it will actually. There it goes. All right, so now we're connected back to the scanner. I guess I just cycled some USB devices and it was not seeing it any longer, but now it sees it. So it sees a little scanner over here. We'll do mostly just the basic options with a few of the advanced features, but one thing with these scanners, since it's projecting light patterns onto an object, it's not really great at picking up objects that are darkly colored. So like you would have a hard time even seeing this camera lens because most of it's dark. The other things it has trouble with are reflective, because then you shine the pattern onto the reflective surface and it gets scattered everywhere. So it's tough with reflective, it's tough with dark, and it's tough with transparent because then the pattern goes through it and it doesn't detect it. There are things you can do. Let's see. Whenever I have surfaces like that aren't reading very well, you can spray. This is actually golf strike spray. So you spray it on your golf club, or I guess you could put it on the golf ball, and you can detect where the golf ball hit the face of the club that you're using. But it also is temporary. So what this does is it looks like a white powder that is easy to wash off of the surface, so it doesn't damage the surface. There are special laser scanning sprays that are similar, and they have a little bit of an advantage in that they're temporary and they just disappear on their own. So I assume they've got some kind of binder that is alcohol based that just evaporates relatively quickly. The downside of those is that they do evaporate relatively quickly, and so you got to get your scanning done before they disappear. But this is cheaper and it's easier to get than the laser scanning sprays, and so I usually use it and it works fine. So if you have a dark surface or a reflective surface or a transparent surface, you need to coat it with something that the light can be projected onto and picked up by the camera. The software does have a dark object scanning mode where it does a little bit better at picking up the darker places on an object. It doesn't really help with reflective or transparent, but it will help with dark objects. And I usually actually leave that on. It is a little more sensitive though, so you kind of get some background noise sometimes. But the objects I have, or the options I have here, are just general. So I'm just generally scanning an object. Dark object, so it's got dark parts, or body, so I'm scanning a human or something like that. So I'm going to put on dark object. There's two tracking modes. So feature tracking is usually the one I use. That's actually the features of the thing you're scanning. So that's what's helping notice where the part is and where each different face is in relation to the other faces of the geometry. If you have a very symmetric object, so like a chess piece that's like the king, it's really symmetric, then all the features start to look the same and it can't track very well. You might have to do marker tracking, and markers are I don't have a little pad of them here. Hold on. Here's some. So they're just these little dots. And they don't have to be dots. Those are the ones that are official. They're actually like a pack of these little stickers is usually kind of expensive. So it is a little better to do something else because they're a little expensive for just being circle stickers. But they are the markers that it looks for. You can even see some of them built into the turntable here. So there are some markers there. But what you would do if you have an object that's having trouble scanning is you put randomly scattered stickers of those dots onto your object and let it track those things. Another thing you can do is just put tape, masking tape or whatever randomly. So you don't want any patterns because you want it to be able to distinguish one location from another on your surface. So just put some random strips of tape on a surface. That's going to do the feature tracking though. The marker tracking, I think it's specifically looking for those little dots. I'm going to do feature with this, although there are dots on here, but he has dots on him too that, it might pick up. I don't know. But we're going to do feature tracking. And with this particular scanner, I only have the option of standard accuracy. So some of the others, you can do kind of a quicker scan or a higher resolution. This one only does standard. So color scanning is, it can also pick up the colors. So the actual, what Iron Man's suit looks like versus just the geometry. I'll leave that on. I don't know that it makes much difference one way or the other. It makes the file larger, but I don't know if on the scan quality it doesn't really make anything different. So I've got him on a little turntable that I'm going to turn on here. So he'll be spinning around, and let's create a new scan. Let's go to, so there's nothing going to happen over here. You won't actually even be able to see the patterns projected onto him. So let's go back to our software. All right, so all those options I was explaining were just over here. They're just little drop downs. So we're going to do a new scan, and it gives us a preview. So I've got down here, I can change the exposure settings. Right now they're on auto exposure, but you could go in and manually change the exposure. This is kind of a preview of what it's seeing on the depth, and the same thing where you can do auto. No, it's actually on manual right now. So I can change the exposure depth. Let's do it auto. Let it pick things out on its own. So this is the RGB. So that's the actual color camera on the bottom, and then the depth camera is the image that it's taking. It's doing 8 frames per second right now. So not super fast, but not super slow either. Over here you've got a bar graph, histogram type plot of, is the object you're scanning too close or too far from the sensor. Right now we're mostly in the good, a little bit in the excellent. I could probably move it a little closer and get a slightly better scan, but then I lose, he doesn't fill in the window. He's outside the window, and so there is a way to deal with that, to patch different pieces together, and we can try some of that. But let's just take the basic approach here, and let's just start and let it do for a little bit. Now I am noticing, you can, I don't know if you can, yeah, you can see it. This little shadow in the background is, since I've got the dark mode on, I just tapped it over there and it kind of went away. Since I've got the dark mode on, it's going to pick up more stuff in the background that are, it sees also. Without dark object on, it usually doesn't see those. And he doesn't really have any dark feature. Let's go to general object, and we'll probably get a little bit better discrimination from the background. All right, so let's start. All right, so it's that green that you see is the geometry that it's picked up, and he's rotating, so it's collecting new data as he's rotating. It's zooming in and out. That's it, just kind of trying to self-center the stuff. It picked up some little dots in the background. It usually does not seem to help too much if you make multiple rotations, but I'll let it go around a little bit, and then we'll see what the next step would be. All right, let's pause there. All right, so now let's say that we can kind of zoom in. It looks like there's some geometry there. If I look really close, it's just a bunch of dots, little dots. So that's called a point cloud. It's just points in space. You can see there's some dots missing. It didn't have a way to see the top of his head or top of his arms. Didn't have a way to see the bottom of his feet or legs or arm. So there's some dots missing, but we've got something that looks generally like Iron Man. So let's complete that one. All right. Now what I want to do is I want to edit the geometry that I had. So go over here, and the first thing I want to do is have it automatically go in and try to make sense of all the points it has in the point cloud. Some of them might be duplicates. Some of them, might be really stray and they're not really part of it, and it'll chop those out. So I'm going to let it automatically do this. Now you can manually control some of these. I'm just taking all the automatic options for these. You can, tweak things and get your setup better, get really good lighting on your setup and everything, and get a better result. But right now we're just trying to get the general idea of how this stuff works. All right, so now let's see what we've got. It's still a point cloud, missing some fingers there. We don't seem to have any real stray. There's a little bit of possible stray stuff right there. I can't really tell. He does have a gauntlet type thing on. There's some stray looking. Oh, that's part of his fingers it didn't pick up. They're kind of small and it might have just missed them. All right, so let's see. Another feature of this is that this software is able, and most all this software works in a very similar way for these things. The software can be better or worse, but they generally work in this same workflow. Let's see if we can get some information about this top part. So I'm going to turn the turntable off, and let's start a new scan. So over here in the project window, I've got that one. I guess I could rename it to make something more. So this would be Iron Man body, just so we can keep track of them. This one, I'm going to start a new scan, and I am going to try to get some of this missing information. So I could leave him on the turntable and reposition the camera. I'm just going to pick the camera up and try and manually scan a little bit. So there you can kind of see. It's going to be tough for me because I'm not exactly sure what it's scanning all the time. But let's get some geometry and see. All right, so this is just me trying to scan some of the stuff that's missing. Let's see if we can. There's also a lag between. Notice it lost some tracking there. And I've got a lot of information that I don't want. I don't know if I can get in on that hand and pick up any of the information. All right. All right, so we got some new data. And we got a bunch of data we don't want, but let's complete that scan. Let's do our point cloud fusion. So edit, point cloud fusion, we're going to apply that. Let it kind of merge and clean up a little bit. Going a little bit slower. I guess because the data was a lot messier. It might have been better for me to just lay him down on the turntable and let it, scan around there versus handheld. But all right, so it did get rid of a lot of the stuff. Let's manually erase some of this. So I've got edit. I've got some options over here, selection options. I'm just going to just totally erase some of the stuff I know I don't want. So I know I don't want any of that, so we'll just get rid of it. I need to leave some information. I didn't get any hand, his hand's still missing, but I did get the top of his head and the top of his arm. So let's go over here, and I've got this other tab called, well, let's rename. This is Iron Man top. Okay. I'm going to merge two different scans, or more, but I've got these two scans, one of his body and one that's got some of the information on the top that's missing on this scan. And I'm going to allow it to try and align this thing, these two different scans, automatically. So it did, it merged them, and now I've got a little more data. Still missing some there, but still missing some there, but I do have some data that I was missing before. So you can kind of keep doing this. I'm missing some data over here. I can try and go get just that scan and merge it together. I don't know if I'll be able to get his fingers. They're just kind of small and just can't find them. But you can start to fill in missing pieces to it. Let's try one more. I don't have a great way. The base kind of obscures some of this, but let's see if we can find a pose over here where I think I can get some missing data from. Let's just do that. So I've got him, let's show over here. Just got him laying down on the turntable. So let's do one last scan. Let's try and get our camera in on him. It's not in the same place anymore. So there, it's kind of close to him. I'm getting excellent predictions over here anyway. And let's just notice it all disappears there. So we'll just see what we get. He does kind of get out of frame. Let's move a little bit over to try and keep him centered. All right, we're going to start that scan. And this might help fill in a couple of pieces under his arms and under his legs. Maybe, I don't know. All right, so it lost tracking right there. I'm going to let it go and see if it can figure out where this stuff fits together. What that means is that basically when that base came around, it obscured. There, it did. It picked up back where it left off. It just had to figure out where it was. So I'm going to pause that, complete that. And so we didn't get any information back there, but maybe we have some new information. I don't know. Let's see. See what we have, if it adds any new stuff. So you could keep doing this, and this will be the last one that we do. We'll try and merge this. So we'll merge our aligned, or previously aligned with the new data. I didn't even rename it, that's fine. And see if it can come up with any better results. I'm not sure that it added anything. Maybe it did, but looks like maybe it cleaned up his left hand a little bit, but there's still a lot. So you would keep doing this. Actually, now you would go through and like, oh, there's some stray things that don't fit anywhere. And you get rid of those stray ones. You know, and there's some strays in there. Because the next thing you want to do is you want to create a actual geometry. So this is still just points. And you want an actual mesh that you could open in Fusion 360 or Mesh Mixer or something like that. So that looks good enough for what we're going to do. So we're going to create a mesh now. And it's going along pretty fast, so it's not taking too long. Now, it does have these big holes in it under his arms, right? So there's some missing data, but now I've got a mesh that I could import into a piece of software to work on further. Thought I did that. Oh, let's see if there's a let's see. Mesh, yes, so I can feel these empty spots. Let's try that. We'll do curves to feel it. So detect the holes, and then you just say, oh, I want to feel that one. And that one, let's fill in his fingers, because they're kind of missing. There's probably a select all somewhere. Let's see. Get that one. There's the. You could either also use this, although I've already meshed him. You could use this for figuring out where you need to get more scan data. There's some little hole over here. And I think that one. I think that's all of them. So it will, I probably should erase that, but let's apply that. So it's going to fill it in with just the best guess, you know. So he's got stubby little fingers over here, but the other parts kind of look okay. You could smooth the mesh if you wanted to. I don't think we need, it's pretty smooth, like any more smooth and we'll lose the little bit of detail that we do have. We might even want to sharpen it, crisp up some corners and edges. Let's try that and see what it does. I don't know if I have an undo button. It looks okay. All right. I don't really want to isolate anything. Let's export the model. And I want a mesh model. I didn't texture it, so it does have colors on there, but we could actually get it to create a texture of his actual suit. I'm just going to get the mesh. And looks like I have choices of a polygon file, an OBJ file, and the STL. Let's use the STL. STL is nothing but triangles, so there's no color no color information or anything like that. It's just triangles. And let's call it Iron Man Mesh. And let's put it on the desktop so I can find it. All right. Save successfully. All right, so let's get out of this piece of software and let's take him into Fusion 360 and see what he looks like over there. We'll try that one. So let's go over here. I gotta make sure. Let's go over here, there. Got too many things running, so it's kind of a little bit sluggish. Let's see. Is this going to pull up Fusion? Yeah, there's nothing there yet. There we got something. All right, so we're just Fusion 360 is similar to SolidWorks, so it's really a parametric modeler where you're building, you know, sketches and extrusions and revolves and that sort of thing. But it can handle meshes. If you want to work directly with meshes, though, probably a better piece of software is Blender. It just has a little bit much different workflow than anything you've used before if you've used things like SolidWorks or Fusion 360. So I'm going to stick with Fusion 360, recognizing that it's not ideal for mesh manipulation. It's really made for built on this parametric modeling idea, but you can use meshes to build other models. And you can, in some cases, if the mesh is relatively simple, you can translate it or have Fusion 360 translate it automatically into what would be like a BREP, a boundary model that is a solid model you're used to working with. But here I've got insert. There's an insert mesh, which is what we have. So I could find, it's going to be on my desktop, isn't it? Let's see. Iron Man, there he is. And there's our mesh. So it actually looks, you know, surprisingly clean and good. So it's not as super detailed as, you know, he's got some missing pieces over here. Looks like maybe even some missing faces back here that I didn't get filled in. Although those could just be shiny, I don't know. Actually, that might just be shiny, the way the texture is. So it's kind of, it looks like the origin is more or less, he's a little tilted, you know, like a little bit. Let's center him. Let's put him on the ground. I don't know where it thinks the ground is. We could go in here and try to, you know, make things a little more uniform. Oh, wait. I'm not too worried about it because we're not going to do anything with him, but you can get the idea. If you have your origin really far off from where you think it should be, it makes doing stuff like moving him around and, you know, all of that kind of stuff, it makes it awkward when you're trying to model and he's not in the center. So spend some time straightening him out, and then now we've got a mesh. Looks like it does need some cleanup down here. There's some missing stuff or just stray pieces down there. And in this mesh tab, you do have some options for working with meshes. Again, this particular type of mesh is probably better worked on in Blender or Mesh Mixer even. In fact, maybe we should open him in Mesh Mixer and see what we can do over there. But you can get these into programs like Fusion 360 where you can do, let's say that this was a scan of our object. This one I probably do want to open in Fusion 360 and try and create a actual geometry around this that I'd want to print. Here, using Fusion's tools are probably not the ideal tools. Let's go into Mesh Mixer and see how you could use this. The downside of Mesh Mixer is that it is not updated anymore, and it crashes often with larger files. But it's free and it is relatively easy to use. Probably a better software solution these days that's free for doing this sort of thing would be Blender. It's a very powerful mesh editing piece of software, and you can have individual control over a triangle, for instance. And so that's probably a better thing for something like this. There are non-free versions that are good also. ZBrush, Mudbox. Mudbox you might be able to get a free license for as a student from Autodesk. Most all of their products have free student licenses, and it basically treats these things as a block of clay. And so you can go in there and you know, trim away, add material, sharpen edges, do all that kind of stuff. And it's a pretty nice piece of software. ZBrush and Mudbox are like that. So let's close Fusion and let's get Mesh Mixer going. And see what, I don't want to save it. See what we can look at in Mesh Mixer. Let's get it over here. So this is Mesh Mixer. I don't remember if I've used it in this class yet this quarter. But this is, like I said, it's Autodesk. Well, it was its own thing. Autodesk purchased it. They have started putting these tools into Fusion 360, but I still like using it on its own. The downside being that it will crash when you are using really large models, so you do need to save often, and it's not updated any longer. But let's import that same Iron Man. And there he is. It has a different control scheme, so I have to relearn where my mouse is. Now, you can notice he is imported like in a weird, there's the ground plane up there at the top of the screen, and he's kind of floating above it. So we might want to transform him so where he's sort of in the right direction. So that things look a little bit normal to it. Oh, he must be upside down. That must be the bottom of it. All right. So he actually needs to go this way, up here, kind of like that. Oh, I didn't want to scale him. All right, now he's sort of in the right perspective from the ground point of view. That'll also help with if I wanted to go print him or something like that, then when I bring him into the printing slicer software, he's more or less oriented correctly. Let's get him a flat base. So there's a plane cut. I can just lower this plane and arrange it where I think a good place will be. And now he's got a flat bottom, so that's nice. Let's say this might be a little trickier, but let's say I want to work on these fingers here because they just don't exist. So I've got these sculpt tools. Make sure, yeah, sculpt tools, and there are like this little drag brush here. I can go. I don't want it to be that large. Let's make it much smaller. Let's get it. All right, something like that, and I can, I can do a little bit of clay modeling type stuff here to make it start to look a little bit better. Whoa, zoomed in too far. This one's got some, these fingers definitely have some trouble. But you could see where, given enough time and patience, you could start to reform some of this stuff. I have other brushes. There's probably an inflate one, so like where he's got these concave fingers, I can start adding some size to them, and so you could do that. There's pinch. Let's see, pinch here. I think pinch would be a good one for, let's see, let's say we want to, I don't know, make this crease here a little stronger, so you can come in there and kind of make the creases a little more obvious. There's smooth. There's a smooth brush. I actually think if you hold down shift, nope. Well, let's just go to the smooth brush, and let's make it a little larger, so it can kind of remove some of that pixelation. Actually, that would be tessellation. So you can kind of smooth him out a little bit, then maybe go back and, oh, I need to add some details in there. So can't remember. There's the crease. You have to wait. That's adding material, isn't it? Well, I don't remember which functions do what. There we go. So you could, try to sharpen up different pieces on there. Given enough time and patience, you could go and do that. That's not what we're going to do today. I just want you to know that there is an option to do that sort of thing. There we go. Now he's got some features. So you could go through and tighten up the mesh and everything, and have a reasonable facsimile. Now this is one of the cheaper scanners. They do have, I think the RevoPop Mini does have a higher resolution. Basically, it's able to project thinner lines on the structured light part of things and extract more detail. This one, is not extracting as much detail. Although, I don't know if you could tell, but this guy, he's, I don't know, what's that, 3.5, 4 inches tall. So he's not very large, but don't think that you're going to get a little 1 or 2 inch tall figure and get all of this detail out of it with this kind of scanner. Other scanners are capable of doing that, but they cost a lot more money. The consumer level scanners generally don't get those super fine details. So they can get you close, and there are scanners that can get closer than what we've got here today. But then you probably still have to go into a piece of software like ZBrush, Mud Mixer, this mesh mixer even, Blender, and really fine tune it if you want the really fine details to show up. The other thing you can consider is that if you print this smaller, so like I scanned a 4-inch figure, but if I print him at 2 inches, now he might start to look not that bad. You know, because I've shrunk down all the details I did get, and they appear more detailed because it's smaller. That's actually how a lot of these things, not anymore, but when they were made by hand, that's actually how this kind of stuff was made. It was called a 3-up model. So you sculpted, usually with like clay, 3 times the scale that you wanted to create, and then you used a pantograph to shrink that thing down to the scale that you want it to actually be at. And so 3-up modeling was the process. Now most everything's just done in CAD from scratch. You don't even have to scan things. Not CAD. I guess it is CAD, but it is not the CAD that you're normally thinking of. It is ZBrush and those type of pieces of software that are made for organic character modeling type things. They're really cool to play with, but like I said, Mudbox you can use for free with a student license. At least you could. ZBrush is not free. They do have a free kind of light version. I can't remember. It might be ZBrush Lite. I can't remember what it's called, but they at one time did have a light version that you could play with to kind of get an idea of how that stuff works. All right. I don't see any questions. Let us. I got a couple of actual 3D printing things to look at here for a second. So let's look at those. I'm not going to save change. Maybe I will print the little Iron Man small just so that we can see how he comes out with. I'll have to go back. I didn't save it there, so I'll have to go back and do it again. But maybe we'll print one at half scale and see what they look like. So speaking of printing and figures, so most people think that the FDM, so the plastic printers like the Ender 3, they don't think of those as being able to create the detail even if you had it in the model, but that's not true. I've got a couple of examples here of these were, I assume, modeled from scratch. So in a program like ZBrush, they weren't scans. But here's one, this little guy. Oh, let's see. That's going to have a hard time focusing. Let's see if we can get him. I think that's focused. All right. So this is a FDM print. He's probably 2.5 inches, 3 inches tall. I'd have to somewhere between 2 3/4 inches tall, something like that. So this is all FDM print. I printed him slightly tilted back so that the supports it did need were all down here on the back side where, you know, that's usually not that important of a location. And all of the front side of him stayed pretty clear. So that's regular, no special, not an album. Whoops. Now I'm all blurry. Let's go back. No special nozzle, just the regular 0.4 millimeter nozzle. It wasn't the 0.6, so it was a 0.4 millimeter nozzle and a relatively thin layer height, like 0.12. So it took a while. It takes a while to print something this long at that layer height, but that is possible. You can drop your nozzle to a 0.3. You can actually go down all the way to like I think a 0.1 millimeter nozzle. Those are really hard to keep tuned because you have to have everything, your E-steps, everything has to be pretty much perfectly tuned, or you're just going to get over extrusion and blobs everywhere and it's not going to look very good. But if you really want to try and get high detail out of a FDM printer, you probably do need to drop your nozzle size a little bit. Although if you consider this guy high detail, then you don't have to. You just 0.4 and do a thinner layer. Make sure you're close on your E-steps, and retraction is okay. This guy probably didn't have a lot of retraction to deal with. Print maybe a little bit slower. Don't try to speed through it. Put them back on their back so any supports are down here, and they can kind of get hidden, and you can get good detail. Here's a smaller one that was painted. Let's see, I'll have to adjust the focus again. There he is. So this is FDM. You might be able to see some of the lines on the back there. Maybe, I don't know if they're showing up. I can't really tell. But he's just smaller. He's like 1.5 inches tall. I guess the spear is maybe 2 inches tall. But he's all FDM printed. So, and again, same thing where it's 0.4 millimeter nozzle, and just a little bit slower printing speed, tilted back a little bit. And now he does have a little bit of well, he's painted, but he also has some primer. There's a couple of primers I like if you're trying to print and paint something. This one is, let's see, this one's pretty good. This is Mr. Surfacer 1000. This is a expensive one, like $11. But it's a high build primer that covers up a lot of layer lines. You have to actually be careful with it because it will cover up a lot of your details if you put too much on there. But it's a good primer for that kind of thing. I don't know if they still make this one, and I have trouble finding it, but this one I like because it's not a high build primer. It is a primer. This is Model Master White Primer. Can't get it to everything to focus at the right time. So this is a good one for if you don't want to hide detail, but you still want to get some primer on there. So you've printed at a thinner layer line, and you're just trying to smooth things out a little bit. Then this is good. And these are usually, I don't know, $6 or something, somewhere in that range. So they're not cheap. If you're printing larger stuff, so you've printed out a big piece and like a helmet, then I usually use either, I don't have a Rust-Oleum here, I have a Duplicolor here. So the ones that say sandable or high build, they will put a lot of primer onto the surface, and that gives you a surface that you can then go and sand and get those layer lines out. Because if you're printing something large, you probably have larger layer lines. Either that or it took you a week to print it. But if you're printing something the size of a helmet, you've probably made your layer lines 0.3 millimeters or more, maybe, just to get through the printing of it. And so you're trying to hide some of those layer lines. PLA itself does not sand very well. It's a very tough material that just doesn't sand. I would actually, if you're going to print large stuff that you want to smooth out, probably try to get your PETG settings nailed down, because it will sand easier than the PLA does. But this stuff sands actually pretty well. So, and it's not that expensive. You get a big can for, I don't know, $8, $6 something. I don't know how much a can of primer is today. But if I'm doing larger stuff, then I'm either using the Rust-Oleum High Build or the Duplicolor Sandable. And usually you can find more options like that at the automotive stores. So AutoZone and that kind of store. Walmart will have them too. Usually, just you might have to look more. There are some other things you can do. So particularly on like the helmet side, the big stuff side, there's a product. Let's see if I can find it. This stuff. It's not super cheap. Let's find it on Amazon. Okay. Here. Yeah. This stuff it's like a resin. It's basically, if you've ever done fiberglass stuff before, it's kind of like just the resin for fiberglass without the fiberglass part. And you paint it or pour it onto your part, and it coats the whole thing. It self-levels, and you get it eliminates the layer lines, but it will also eliminate some detail. Notice in their little picture here, they don't show the stuff being applied to like his teeth, because you're not going to lose the teeth, but you're going to lose the sharpness of the gum line there. It's going to fill it in a little bit. But this stuff is easily sanded. You do want to wear like a respirator thing because you don't want to breathe the sanded particles of a resin. But it does, if you're doing larger scale stuff, then this is a good option for eliminating the layer lines and then having something that's really pretty easy to sand. It looks like it's $30 for 6 that's probably 6.4 ounces is probably enough to do like one big item, but it's not that much more for the 24 ounce version. It is, it is a chemical 2-part thing. Pour part A into B or whichever and mix it up and paint it on. It does get hot, so it does work with PLA. It doesn't get so hot that it'll deform PLA, but it does heat up, and it's messy, so you do have to outside and gloves and all that kind of thing. But it is an option if you're trying to create some large parts that you want to get rid of the layer lines. Let's see. Oh, here's two of our not new, but the two new vases that we're going to look at, two new materials. Let's go over here. I'm tired of messing with that camera. This one does a little better on auto focusing. So this one, see if I can find where I'm at in the camera. There I am. All right. So this one the material isn't anything particular, but what's going on here is I've used an option in Cura called fuzzy skin. So it's you just type in fuzzy into Cura and it will take your regular geometry, so it's the geometry the same as like this guy, it's perfectly smooth, and it will add noise to it. So same geometry but with fuzzy skin, and it adds this texture. You can control the severity of the texture, how much noise is in it, with a couple of parameters that it has. I think you can control if it's on the outside or inside or everywhere. I don't remember if that's part of the option or not. But if you're trying to, it does help hide layer lines, so you can't really tell that there are layer lines on it. And again, I'm having trouble focusing here. It just won't focus that close. Maybe we have to go back down there. All right, so it kind of hides the layer lines and creates this grippy texture on it. So it's good for like if you're making something that needs to be grippy, or you just want to kind of hide the layer lines and you like the texture of it, then that's fuzzy skin and Cura. And then here's just a sparkly filament that I found. So this one I had a sample of. You can get filament that has particles in it. With those that have particles, same thing as always. It's not necessarily that all of the particles are abrasive, but on a smaller nozzle or even a 0.4 nozzle, you can have trouble with something like this. Those little particles can get jammed in the nozzle, and create temporary clogs. So if you're printing a filament that has a lot of embedded inclusion type things like this, probably best to try a 0.6 millimeter nozzle just to kind of ensure that it's not going to get clogged with the stuff that's in the filament. This is just a PLA. I don't remember what it's called, but a sparkly one. Kind of interesting. All right. Next time, so that'll be Friday, we'll look at some more of these things. Maybe we'll have some geometry for this piece. This is the one I actually want to recreate. If that goes well, I'll show you what I get. If it goes well, I'll show you how we actually made this in Fusion 360 and can print it. I'll also see if we can print a scan half scale of our Iron Man, just to see what kind of resolution we can get when we shrink him back down to a smaller scale, if he looks good or not.